Okay, this is 6.20, and it's kind of combining what we did in the other few problems. We're going to write the symbols for each of the ions, and then we're going to name the ionic compound that's formed. This is one of your back of the book problems, so I'm only going to do the first and the last. So for A, we want to write the appropriate ions for calcium and chlorine. What that means is we need to write the ion that calcium forms to be stable. So remember, calcium is in group 2. So here's our calcium. He's in group 2, which means that he will lose 2 electrons. So he will have a positive 2 charge. And any ion in group 1 will have a plus 1 charge. Any ion in group 2 will have a plus 2 charge. So that makes it a little bit easier to name these. These are transition metals, and we will work with those in a little bit. And then our non-metals will have negative charges. They'll be ions of negative charges. Okay, so we have calcium 2+, and now we need to write chlorine. So chlorine is in group 7. Here's chlorine. And that tells us that it has 7 electrons in its outer shell, so it wants to gain an electron. So if it gains a negative charge, it's going to be chlorine -1. And just like the problem we did previously, we're just going to bring down these charges and write them as our subscripts. We're not going to overthink it. We are balancing the charges, and we're just bringing them down and writing them as our subscript. Okay, so now we have magnesium and oxygen. And remember, we want to write the ion symbol first. So magnesium is in group 2. So it's going to have a 2+ charge. And then we had, what was the oxygen? Here's our oxygen is in group 6, which means it needs 2 electrons. It has 6 electrons in its outermost shell. It needs 2 electrons to have a full octet. So it's going to gain 2 electrons. So oxygen is always 2-. And anything in group 6 is going to be 2-. Anything in group 7, 1-, and 3-. Now we're just going to pull our charges down. We're not going to overthink it. We're going to write our charges as our subscripts on the opposite element. So we would get magnesium 2 oxide, except that when you have 2 of the same number, or let's say it was this, it would never be this, but just pretend with me. We can make that smaller. We can reduce that, right? So since we have magnesium 2, oxygen 2, we can just say it's a 1-to-1 ratio. And again, this would never happen, but if it did, then we would say we had 1 magnesium for every 2 oxygens.